All right, let's go ahead and talk about nuclear reactions. This will be the last item for this unit. The first one we need to talk about is nuclear fission. I'm sure many of you have heard about this. There are really two main applications of nuclear fission. One would be the controlled fission reactions that produce a lot of usable energy. This would be the way that nuclear power plants work, and we'll talk about those in a moment. Or, of course, you can have uncontrolled fission reactions, which create nuclear weapons, like the atomic bomb. Let's briefly talk about how this works, and it's a fairly simple idea, but it's very difficult to achieve. Okay, so we have a fissionable nucleus of uranium 235. Okay, it has to be a particular isotope that's known as a fissionable nucleus. You bombard that with a neutron directly into the nucleus, and it results in the splitting of this nucleus into two different nuclei that are smaller. Okay. As a result, neutrons are released, which continue this process and bombard other fissionable nuclei. Neutrons aren't the only product of this. The main reason that nuclear fission reactions are useful is that they produce an awful lot of energy during this reaction. So each time that a fission reaction occurs, enormous amounts of energy are also produced. And that energy can either be usable if it's controlled, or it can be usable as well if it's uncontrolled. All right, so we'll talk more about this and we'll watch some videos. The uses of fission reactions. So, like I was mentioning earlier, nuclear weapons are one obvious example of fission reactions, and alternative energy, so energy that does not require fossil fuels, is a result of development from nuclear weapons. So, you may have heard about nuclear weapons or the atomic bomb from your history class, the Manhattan Project, the development of the atomic bomb. I have a video for you here that I highly suggest you watch. This is one of my favorite videos of the year. It's from Vsauce. So I would suggest that you pause this video, open the notes, and watch that, and then come back. On the flip side of this, you can have alternative energy. So these large nuclear power plants that you can see here, the only thing that they produce is water vapor in addition to the massive amounts of energy. However, they do present a problem. You have to store the products or the used up fissionable nuclei. You have to find a way to store that safely. And this is actually a picture of in Tooele, Utah, right? Our backdoor neighbor here. This is Energy Solutions, and they are in charge of using these large facilities to store the waste products of nuclear fission reactions from these power plants. Another problem, of course, would be when nuclear power plants have accidents, like with Chernobyl or 9 Mile Island, right? So I suggest that you watch this video as well that talks about how nuclear power plants work, and that'll give you a good compare and contrast between the two main uses of fission reactions. All right, so that was nuclear fission. Now let's talk about what is the energy source of the future, right? So this is a constantly debated topic. We know that fossil fuels create greenhouse gases, and eventually those will run out. So we need to find an energy source for the future. And that brings us to our next nuclear reaction, which is presented in this video. Okay, so again, I'm not going to make you watch this video in the notes, but I highly suggest you watch this video. It talks about nuclear fusion and how that could potentially be the solution to our energy demands. Okay, it's a fairly long video relatively to the other ones that I show you, but it's really important. Okay, so I'll give you time to do that. I'll move on here. Lastly, we need to compare and contrast nuclear fission and nuclear fusion. Okay, so these are the two nuclear reactions that we're talking about in this class. First of all, we have nuclear fission. So that would be the bombarding of atoms with neutrons, resulting in the splitting of the nucleus into smaller atoms. Contrasting that with nuclear fusion, when nuclei combine to produce a nucleus of greater mass. So this one involves splitting, and this one involves combining. So those are the obvious differences there. The next one, uranium-235 and plutonium-239, are the fissionable isotopes that are used within nuclear fission. And for fusion, you typically use small isotopes, and they are hydrogen. So the sun contains a lot of hydrogen, the universe does in general, and that is how our sun produces energy, nuclear fusion deep within the core of the sun. It requires temperatures in excess of 100 million degrees Celsius, which is the main reason why nuclear fusion is not a viable option here on Earth right now, because the energy demands to create such high temperatures make it a pointless energy alternative, because you're using more energy than you get out. But hopefully in the future, scientists can develop a way to make this more efficient. And lastly, nuclear fission results in a chain reaction, okay, like you saw in that picture earlier, that is either controlled or uncontrolled, like I said. And nuclear fusion, however, is a process continually ongoing in the sun. Okay, this video you can watch, and it will further explain the difference between nuclear fission and fusion, and it should help prepare you for assessment 1.4, which is to come later in the module. Okay, if you have any questions, let me know. Otherwise, thanks for watching.